Welcome to session number 2 in the series Digital Multimedia Processing. And here in the last session, I just gave an overview of image processing, what is an image, and stuff like that. And then I uh, opened an image in MATLAB, and then I separated their colors and stuff like that. Now, that was using MATLAB, but for some reasons, if you want to learn, I feel that if you want to learn image processing, you should be able to write algorithms, not use the algorithms from MATLAB, but write your own algorithms, right? And that too, you can learn the concepts if you can do this in C. So what I'm going to do in this session is I have got some sample images. Okay, so there are two colored images which I have. Then there are all black and white images. But then if you look at the black and white image also, it will, so let's say if I go to properties, okay, so it's a BMP image, right? So all of them are BMP images, but what's special about this is these are not 8-bit images, these are still 24-bit images. So that means that there are RGB here also, but all RGBs are same. So if all RGBs are same, then it will turn out to be a grayscale, right? So that's how you can also convert into a grayscale. For example, I can take this image, which is a colored image, and I can still have the RGB frames, but then all the pixels of RGB frames are going to be same. So in that case, it will become a grayscale. So let's start doing something with these images, right? So first of all, what I'm going to do is I'm going to write a program to read from different images, and then able to manipulate pixel by pixel. So basically I'm going to do some photometric correction as I told you last time. So let's go ahead, launch Visual Studio, and let's make a new project here. So let's make a new project here, and this will be an empty project, and I will call it as Image Processing System, IPS. Okay, so I'll call this as IPS, and it's an empty project, C++, and say okay. So first and foremost, I am just going to deal with BMPs, not with JPEGs and other formats, unless I go to compression and all that stuff. So later on I will take on other formats, but for now I'm going to focus on BMP. So now let's see, if I say bitmap header, okay, so bitmap header, I would have a bitmap format, right? So I'm going to read these 2 bytes BM, and then I'm going to make 2 structures. One is for the image information, which is going to be 12 bytes, and then I am going to make the header info, which is going to be 40 bytes, right? So this is over here 40 bytes. So let's do that. So first of all, I'm going to just make a header file. So I'm going to say add new item, and I will call this as data structs. So these are my data structures. Okay, so I will call this as data structs. Okay, and say add. Okay, so now I hope that my font size is comfortable for you to see what I'm typing, or if I can make it bigger so that it can be clear. So if you comment, please let me know, if this is comfortable. Okay, so what I'm going to do is I'm going to make a structure. So I'm going to make a structure, and I will call this as img info, right? So this structure is going to store file information, file, correct? And let's do this structure here. Okay, so I am going to deal with all unsigned characters, right? And I will have a file descriptor first, so that is B and M. So file descriptor, DCP, let's say 1. Okay, so then I have 2 of this. file descriptors 2. Okay, so I have two file descriptor. One is going to be B, other is going to be M. Okay, then unsigned int file size. So I'll say file sz, and unsigned int, then I will say this is a reserved word, rsv. Then I'm going to say unsigned, sorry for the spelling mistake, and then I'm going to say another integer which is going to be image offset, img off. Okay, so this is going to be my first structure which will read the top 14 bytes over here. Okay, top 14 bytes over here. The next thing which I'm going to do is another structure, and I will call this as Bmp HD. So this is a Bmp header. Okay, it stores image information. Okay, and here I'll create that structure. So I will have unsigned int. So I'm going to copy this so that I can Control C. So unsigned int, and I will call this as HDSZ. So this is the header size. Then the next one I'm going to have is width in pixels, wpix. Okay. Okay. Then I'm going to have height in pixels, that is hpx. Okay. Then I'm going to have number of planes, which is going to be a short, right? Short. So this is over here. If you are confused, in the header you see that this is going to be a short which gives the number of planes, right? So that's the short. So I am going to say this is num pln. So this is number of planes, and then you have got bits per pixel. Again, this is a unsigned short, right? So unsigned short, which is going to be bits per pixel. Okay, so this is going to be that. Then I'm going to have an integer which says if there is a compression. Okay, so instead of typing, okay, fine, I would call this as compress. So this will tell about what kind of compression is there, right? So if you go here in the bitmap header, you can see the compression, right? It's a 4 byte. It says if it is 0, then there is no compression. If it is 1, then there is a 8-bit run length encoding. Then if it is a 2, then it is a 4-bit run length encoding. So that's the compression information for the BMP. Then I am going to have image size. So I'm going to have another image, this thing which is called imgsz. So this is going to be image size. Next one I am going to have is called x resolution. Then I am going to have, or rather I would say this is your height resolution, hres. And then you have got width resolution, that is wres. This is in pixels per meter, right? And then this is number of colors, and in case of 24-bit image this will have no meaning, but in case of 8-bit image it will tell you how many colors are there. So let's call it number of colors, CLRS. Okay, and then important colors. So that's another integer which is called important. Okay, important colors. So this is my header which I'm going to read to get the image information. So I have saved that header. Now the next thing which I'm going to do is create a file to where I will have all the image reading functions, right? So where I will just read images, right? So let me just do that. Okay. So first thing, I'm going to name this as a C file. So I'm going to add a new C file here to the project and call this as img read. Okay, and this is going to be a C file, img read. Correct? So it is going to be about read functions for reading the file. So I'm going to say add, and then equivalently I will also add a header for it. So whatever functions I create, I will create the header side by side. So that header will be called the same thing, which is img read. Img read. Okay, so that would be the header file for that. So let's go ahead and write first of all the functions in this. So first thing first is I should define hash define what is called CRT, secures no warning, right? No. Okay. So this is so that you can use IO functions because they are deprecated, right? So this is to disable that deprecation. Okay. Then I can say hash include, and first thing is going to be your stdio.h. Okay. So that's that. Then you are going to have stdlib.h, stdlib.h, right? And then you are going to I'm going to use stdbull.h, hash include stdbull.h, correct? And then I'm going to include my own header file for the data structure. So I will say hash include, and I'll put this time in the double quotes, and this is called data structures. So now this is done. Now I'm ready to write uh, the function to read the image information, right? So it is going to return nothing. Okay, and to this, so let's call this function as im.info. So imf info is in MATLAB, so this I'm calling as im.info, and in this case it is going to read a character string which will tell which will basically tell you the path. Okay, and it will receive yeah, so it is going to receive uh, a structure which it's going to fill, right? So that structure again is going to be struct. So first structure is going to be file info, right? img info. That file info is called img info. Okay, img. So where's the problem? Struct, then bmp. So in this data structure that will be there, right? Bmp hd, img info bmp hd, bmp hd, right? So these two structures, and now these are structures, but I will name them. Okay, so this is inf, and this one, so these are pointers to this structure, which I am going to pass on to this function to fill it, right? And I will call this as bmp header, correct? And then I am going to pass on another variable to say whether I want to print the information which is extracted, right? So I'm going to say echo or no echo, right? Okay, so this, I'm ready to write this function. Okay, so unnamed prototypes are not allowed, so I will call this as fpath. Okay, sorry. Okay, so now this is a function. Let me add a text. Uh, Function to uh, read image information, right? So this is a function to read image information, right? So here, first of all, I am going to open a file, so I need a file pointer. So there's a file pointer here, and I will call this as fp. Okay, and the next thing I'm going to do is I'm going to read inside a character when I open this file, byte by byte. So I am going to create a character like this, and then I am going to have a integer so for now let's just do this much only. Then I'm going to say fp is equal to fopen. Okay, and in this case I'll do a fpath. Okay, comma, read only binary mode. So this is a read only binary mode. So I'm going to open that file. Then I am going to check if the pointer is returned is not null. So I will check if ft is equal to null. So if it is null, then I will pass on the information to the user that failed to open the file. So I can say printf failed to open image, or failed to open input image, right? And then I'm just going to say return, and this return is void, so I can just type that. Else I am going to do the processing, right? So here I can do fread, and I can read the first byte. So I'll pass a pointer to ch, and size of character, and then I'm going to read one character, and then I'm going to read uh, from this file pointer. So from this file I'm going to read. Okay, so this will read b. Okay, and I'm going to save it, right? So this is a pointer to a structure, right? And then I have to dereference it, and then this is where I'm going to store this first character, right? And then I can just repeat this. So I will go here and repeat this for the second one. Okay, and basically I am doing because I wanted to separate character by character, right? So that's why I am not reading the structure altogether. Okay, because this is clubbed as a short in the structure, right? So I don't want to mess that up. Okay, let's see the structure. Unsigned character, so I can, right? So why do this? So what I can do is I can directly read okay, I can directly read okay, so I can directly read this rather than reading character by character. So here I'm going to pass a pointer to the structure, which is IMF, IMNF. Okay, so I'm going to read that. So that's basically going to be size of IMINF. Okay, so that's going to read the first structure, right? Then I'm going to say fread, and I am going to take the second structure, which is bmphd. So it's already a pointer. Then say size of bmp right, and then I'm going to read one structure, and then I'm going to read from this file pointer. Oh, so there is a spelling mistake. So this is called Bmp Header. Okay, so that's called Bmp Header, and that's also called Bmp Header, right? Okay, let me just make sure. What is it called here? Bmp. That's fine. So I'll call this as Bmp Header. Okay, so I have read the file information. Okay, and then I'm going to close the file. Okay, and once you have closed the file, I am going to write another statement that if echo is true, then I'm going to print all this stuff, right? So then I am going to print all this stuff. Okay, so this is going to be little elaborate. Okay, so first of all I want to do a print the file which I have opened. Okay, so I would say %s new line. Okay, and here I'm going to put in fpath, correct? And then I am going to say I want to, what are the signatures? So I'm going to say printf okay, percentage. So here I will call file signature and file information. So I'm going to pass on the file information, and let's say this much, and then I will go new line and I would say file signature. Okay, and then I would do %c for a character, %c for a character, and then here I'm going to put IMINF. Okay, IMINF file descriptor 1 and IMINF file descriptor 2. And then for a trial I'm going to run this, right? So there has to be a semicolon here. Okay, so I'm going to run this, then add other printf lines. So I'm going to create another C file and say add new item, and here I am going to create a C file. It's going to be process main. Okay, so this is going to be a main file for processing it. Okay, and here in process main I am going to just call that function. So before that I am going to include all the header information, right? So all the include files. So let's go here. At least I will need these, right? Control C, and process main I'm going to say Control V. So I have that. Then I should have at least this header. So there is a read here. So there is this function which has to have a prototype there. So I just copy this into the header, and here I can just put a semicolon, and if I want I can remove all the names of the variables because all it needs is a type. So this is a prototype. This is a prototype for that function which is written in this file, and this is going to be included in the header file over here. So I would say hash include, and I will say image read.h, and that's it. Okay, so once you are done I can say int main, and here I can say void, and here I can call that function. But before that I need to create a structure. in which I'm going to receive the information, right? So img info, right? So that's over here. Let's call this Control C, Control V, and I will call this as IMF info, and then I'll create another structure which is called Bitmap Header, so which will be basically this one. Control C, Control V, and this one I will call BP head. Correct. Now all the information we have read is going to be returned back to this main function if I pass the pointers to. So if I pass by reference these structures, right? So all I need is to call that function. Okay, so to call that function, I will just copy from here. So I'm going to call this function in here. Okay, so here first of all I need to pass the path. So I'm going to say that character and say f path is equal to, and I'm going to put here the path to the image. So for example, I'm going to work with this image. So I'm going to get to properties and I'm going to copy this path. Control C, Control V, and then I'm going to copy the name of the file. Okay, Control C and Control V. Then I'm going to, this is going to be interpreted as a escape sequence, so I'm to put here another backslash. Okay, so here I'm going to pass here f path. Okay, and then here I am going to pass the IMF info, and here I am going to pass BP head, and here I am going to pass true, so it's going to print. Okay, what's the problem here? Oh, I forgot a semicolon here. Okay, so okay, I have to mention here I have to pass the, not the structure but the pointer to the structure, right? Okay, so that's how this function is written. So let's see if this builds. So let me just extend this up. Okay, so it has built. What happened to this? But it says unreferenced ch. Of course, there's this ch which is never used, so let's just remove that. Okay, so this is our final rating, and let's build this again. Okay, that's all you should see. All you should see is just this line, and it says 1 succeeded, 0 failed, 0 up to date, and 0 skipped. So that means that this is error free. So now if I run this, so it says this is the file I passed, this is the file information, and file signature is BM, right? So very quickly I'm going to add the other print statements, and my function, which is the IMF info, is complete, right? So here I am going to just quickly write printf, just 1 second, file size. So the next thing is going to be file size. Okay, and this thing is going to be %d, and this is going to be the from inf, and this is going to be dereference to file size. Okay, so that's what it is. Okay, So I am going to print here the file size, then the reserve keyword. So I'm just going to say Control C, Control V, and I'm going to put here reserved word, reserved, reserved word, and this reserved word is going to be RESV. Okay, the next one I am going to put here is going to be data offset or image offset. I will call this as data offset. Okay, data offset, and this one is going to be 54 because this is where your data starts from, right? So that's that. And then I'm going to print the header information, right? So I'm going to say printf header information over here. Okay, file information, and then here I will put here header information, and here I'm going to put a new line character, right? So that I print it on the new line, right? And that's it, and I don't need all this stuff. So I'm going to put in the header information here after this. So I'm going to do so first thing is going to be header size, right? So I'm just going to copy this one, Control C, Control V. So here is going to be header size, header size, and here I am going to put that header is called Bmp header, Bmp. Okay, and here Bmp header would have, okay, how come IntelliSense didn't read it? Did I do a typing mistake? Bmp header. Oh, let's see. Bmp header. Why doesn't it give the information? Okay, so what's in the Bmp header? Header size, right? HDSZ. So why is it not reading? I'll try to understand this first. Oh, there is a mistake here. That's why it's a problem. Okay, I know what's happening. Okay, what you are reading here is this. So this is structure. Oh, this is the content of Bmp header. Just wait a second. Okay, so there was a little mess up. I'll explain you. This name I have written wrong, so that's why it was giving a problem here. So anyways, so I'm reading this information, right? So now this is fine. Now this is fine, right? Now here I am going to write header size, right? So HDZSZ, header size. Then next I'm going to write here Control C, Control V. So header size, after header size we have got image width in pixels, right? So I will say image width in pixels, right? And this is going to be that. So it's going to be image width in pixels. So that's what it is going to be. Next is going to be image width, image height in pixels. Okay, so image height in pixels. So that is going to be HPX. Okay, so once you have that, then you are going to have number of image planes, right? So number of image planes, and this one is equal to num planes. And the next thing we are going to have is bits per pixel, right? So printf then I'm going to here have bits per pixel, right? %d, and here I am going to put here Bmp header, sorry, and then dereference it to bits per pixel, which is this. Then the next thing I'm going to put here is going to be the compression, right? So next thing I'm going to put here is compression. So that compression is going to be comp something, com per compress. The next thing I'm going to put here is going to be height resolution, right? So it is going to be image size, sorry. So this is image size is file size minus the header, which is 54, right? So here I am going to have, so let's see if I have image size over here, imgsz, right? So image size, and this is going to be imgsz, right? And the next thing is going to be the height resolution. Okay, height in pixels per meter. Okay, and this is going to be height resolution in pixels per meter. That's going to be that. And then I'm going to have the width resolution, right? So I'll just copy this, and I will put here width resolution in pixels per meter, and this is going to be wres. Okay, so that's wres, and then import number of colors. Okay, printf, okay, sorry, number of colors, and %d, and the number of colors is going to be Bmp header and dereferencing operator, and it says number of colors, and then I'm going to put here important colors, number of important colors. Okay, number of important colors, and this one I am going to do as num, no, that goes as impclrs. Okay, so here let's count whether I have read this properly. Okay, so this one is going to be 2 bytes. This is going to be 4, 4, 4. So this is 14 bytes. This is going to be 4, 2 the 8, the 12, 12, 16, 20, 24, 28, 32, 36, 40. So what did I mess up here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have got 11 entries. So let's look here. So I have got size, width, height, planes, and bits per pixel. So size, width, height, planes. So this is 12, this is 16. Then compression, that is going to be 20. That's going to be 24, 28, 32, 36, 40. So what went wrong where? So let's write it down. 4, 4 is 8, 4th is a 12, 12 to 14 to 16, 420. Why there is a width in pixel here? Okay, so this is wrong. Okay, so that was extra. Okay, so such checks you should make. Okay, after compress there is image size. So after compress there is image size here. After compress there is image size, then x pixel resolution, y pixel resolution, and then that's it. So that's done. So let's try to run this on the same image and try to print information. So I'll say build solution. Okay, so there is no unnecessary warnings here. So I'll say run this. Okay, so it is a bitmap. File size is 12. Reserve word is this. Data offset is this. So this is all wrong, right? So this I have read wrong, right? Okay. What happened? Why is it reading garbage? Let's see where it has started reading garbage. Is header size is wrong. Reserve keyword, file size, everything is wrong here. BM is correct. So unsigned car, integer, integer. 4 to the 8, 4 is a 12, 13, 14. So it has read that this is 40 bytes. And this is 16. Why this is 16? Why this is 16? Let's check. This is 8, this is 8, this is 4. So this is 1 byte, this is 1 byte. And this is going to be 4, 4. Why this is 16? 16. This size is 40. This is correct. Why this is 16? Okay, let me just figure out. Put you on pause. Okay, so this is a new learning which I'm seeing. What I'm seeing here is, for somehow it is not able to resolve a character or a short here. It's always showing here a 16U, which means it's always taking a Unicode for these two characters. So it doesn't make sense to me. C should not behave like that. But in any ways, what I can do here is, instead of reading signed character ch, if I do this, and if I say fread, okay, and ampersand size of, so I'll read it in a character, and I call this as size of character, right? And this should be 1 unit. isn't it? So now what's the problem? Okay, so fread, and then I can say img info. This is kind of strange. Sorry, inf file descriptor 1 is equal to ch. Wow, I have to manually read it. So there's something messed up with the Unicode thing. So it's picking up whatever it wants to pick up in a header file. It is header file, it is picking up a Unicode character. So I understood that. So a header file, it's picking up a Unicode character. Okay, because it is a header file. In C file, it is picking up as a single as a ASCII character. So for somehow, if you create a structure in a header like this, then this is going to follow Unicode for characters. Okay, so that's a new learning I have. Okay, so now this is going to be descriptor 2. Then I'm going to read an integer. So I am going to create an integer here. And here I'm going to read the integer and size of integer. Right, and here I'm going to say the file size. File size is integer. So this is kind of funny, but that flaw is there anyways. So this is going to be the reserved word. Right, and then I am going to do, this is kind of funny. Okay, so then I'm going to do here reserved word, and then this is going to be the image offset. So now everything should look okay. Okay, so this is a new learning for me. Build solution is done. Let's start without debugging. Okay, so now everything looks correct. It's only that this first two it is taking as a Unicode character. Okay, so now the file size is this one, reserved keyword is 0, data offset is 54, the header size is 40, and then there are 512 pixels for height and the width. Number of planes is 1, pixels per bit is 24, compression is not there, image size is this minus 54 is that, and this is the resolution in pixels per meter, and this is number of important colors. Number of colors is equal to 0, number of important colors is 14. So this is also kind of, oh, there's something else which I'm printing, is it? IMPSCLRS. Important colors. So hang on a second. Okay, so everything looks okay here. Okay, so I'm able to read. So if I run this, I'm able to read the information of the image file. Okay, so now what I'm going to do is I'm going to do the next thing. Next thing I want to know is, because for the black and white also it is reading as a 24-bit. So let's make a change here. For example, here let's put here a black and white image. So let's pick up our image from here. Let's say this is going to be called plant cell. Okay, so plant cell.bmp. Okay, so if I do that, and if I build and say debug, start without debugging, so it still says it's a 24-bit image, and it is turns out to be gray scale, but it's not a 8-bit image. So that means that they are repeating the same for RGB, right? So we have to write a function to figure out you know, whether it is a black and white image or not. So the one simple way of doing this is I am going to compare the number of pixels, isn't it? Okay, so I am going to compare the number of pixels and then say you know, if the three planes are matching in pixels, then I can say that this one is a black and white image. Okay, before that let's write this to separate the planes, red, blue and green. Okay, so I want to do RGB. Okay, so let's here write another C file. So everything looks okay now, right? Okay, so sorry for the mess up. Okay, so I am going to here write add new item, and new C file I'm going to add is image write. So up till now I have been just reading images. Now I'm going to write image. Okay, and here I want to do all the same what you call the same includes, because I'm going to deal with file, right? So okay, so having done this, okay, so what I'm going to receive here is the path of the file, and then I'm going to write to three files. So basically, so I'm going to say void, and here is split colors, right? And here I want to say I want to receive the path of the original file. So that's what I'm going to say, and I'm going to also write the receive the path of the destination file, which is going to be R path. Okay, then character G path, and then character B path. Okay, so I am going to receive this, right? So I am receiving four paths. One is the original file, and then there are three files which I am going to write. Okay, and here I am going to write to this processed folder. Okay, so let's delete that. So I'm going to write to this processed folder I want to write to. So I'm going to put that path, right? So here I am going to first say file, and then sorry, and I am going to create a pointer to that file, which is that. Then I'm going to do three more files for red, blue and green. Okay, so one is going to be red, other is going to be blue, sorry, green, and then blue. Okay, so these are the files I'm going to write to, and then I'm going to say unsigned character ch. This is the byte by byte I'm going to read it. Then I will also have an unsigned character, which is ZR, which is a 0, right? And then I am going to have unsigned character for the width of the file, width of the image, the height of the image, the image size, IMSZ image size. Then I am going to have data offset, right? So these are going to be my integers, right? So okay, so first of all I'll try to open the original file. So I would say fp is equal to fopen, and here I am going to pass the path fpath, and then I am going to open it in read binary mode, and that. Then I'm going to check if fp is equal to null. Then I'm going to say that printf uh, failed to open the input file. Okay, and then I'm going to say return. Okay, so that's what if I'm not able to read it. Now if I succeed in reading it, so I have to put here else. If I succeed in reading the file, then first thing I'm going to do is put the pointer to the data offset. So I will say fseek, and I am going to put this pointer to 10th location where I get the data offset. Okay, and I'm going to read the data offset. Okay, so here I am going to read the data offset. So I will say fread, and then I want to pass the pointer to the integer, which is going to be data offset, and then I am going to say size of, so this is kind of dangerous now, this is going to be a int. Then I'm going to say one count, and I'm going to say fp. So basically this will read the data offset where the image data starts. Next thing is I want to read the width of the image, which would be at 18th byte, and so this will be the width of the image in pixels. So here I will pass on w, sorry, so here I'll pass on w, and then adjoining to this I would have the height. So I will just do another fread, I don't have to place the pointer, and say h. So I'm going to read the height. Then I'm going to say the image size, im size is equal to width into height. Correct. So these many pixels are there. Then I'm going to open the write files. So I'm going to say fr is equal to fopen, and this is going to be sorry, yeah, so I'll have to give the path, right? So that will be our path, isn't it? And then here I'm going to open this in the write binary mode, right? So that is there. Then I'm going to open the path to write a green file. So I will say fg is going to be g path, and then I'm going to say fb is going to be b path. So I'm going to pass this path to this function. Then I'm going to check if these are, if any of them is a null pointer. So any means I'll have to do a or. So I'll say fr equal to null. Okay, so this is one condition. So unless I am able to open all the three files, I would not proceed. Then I would say, sorry, I would say if fg is null. Okay, if fg is null, and the final thing I'm going to say is if fb is equal to null. That means it has failed to open the write files to write. So I'm going to say here printf failed to create component files, right? And then I'm going to have a return. So if this doesn't succeed, that means I'm not able to write to a files. Else I am going to, so now I'm successful here. So I'm going to put the file pointer fseek to the for FP as 0 0. Okay, so first thing I'm going to do is I'm going to copy the header, right? So I'm going to copy the header. Okay, so I can just run for int I equal to 0, I less than, so offset. Okay, so it will be called data of and I plus plus. So here I am going to copy up to the point where the data starts. I am going to read and write all those characters, correct? Okay, so I am going to have a f read, and here I am going to say f character. So this is going to be 1 unit, size of character, so size of character and 1 unit and file stream. So that's I'm going to read. Then I'm going to say f write. I'm going to write the same character and size of Unicode, not a Unicode, this should be ASCII, 1 unit, correct, comma FP. So I'm copying the header information in image information. So I'm just going to repeat this. So this I'm going to write to FR. Okay, Control C, Control V, and Control V. So then R, G, B. So I have written to 3 files this. Then I am going to copy the data, right? So I'm going to say for int I is equal to 0, I less than, the total size of the file is in IM size, okay, comma, and the I plus plus, and here I'm going to copy the image. So what I'll be doing is I'm going to read character by character, right? So 3 characters means RGB, right? So I'm going to say f read. So I can just do this one. I can just copy this one. Control C, Control V, and here I am reading 1 character, and then I'm writing this over here. I'm writing that character to FR, and then to other locations I'm copying 0, isn't it? So I'm writing to other locations, I am going to write 0. So this will be green, and this is going to be 0, and this is going to be blue. Okay, so I have written one set of pixels I have written. So one byte I have written for the three planes. Then I'm going to repeat this, and this time I'm going to write to this one as a 0, and to the green one I am going to write character, and to the blue one I'm going to write 0. For the next case I'm going to repeat the same stuff. Here I'm going to write 0, here I'm going to write 0, and here I'm going to write the character. Okay, so once I have done this, I should be able to just close the stream, file stream. Right. So before I close the file stream, I want to flush the buffer. So flush, so f flush, and here I want to flush the red stream. Okay, and then I can flush the green stream. So here I'm going to flush the green stream, and then I'm going to flush the blue stream. So if there is anything in the buffer, it will be forced to be written to the hard disk before it closes. Then I can say fclose, fclose, fp. Okay, so I want to close fp, fr, fr. Then I want to close fg, and then I want to close fp, fb. Okay, so now I have closed all the streams. Okay, so we have done this function, and we will put this in the header file. So image write header. Okay, so I am going to put here an image write header file. So I'm going to add a new item, and here I'm going to add a image write a header file, right? Image write header, add, and I am going to take that function prototype over here, Control C, and I'm going to copy it to the header. Over here is Control V, and done it. And I don't need these. Correct? So this is my function prototype. And then in my main program, I have got the information about the file, and next thing I'm going to do is I am going to write it. So what I'm going to do is I am going to put here R path, and here instead of this I will call this as processed folder. So basically that's that folder, processed, and in that I want to write r red.bmp. Okay, and then I can create another one which is a green path, and this will be called green.bmp. And then another one which is going to be blue.bmp. Okay, and so once we are done with this, I can call that function. So from the header file, I know that the function should be of this form. So I will go here and I will put here the f path. Then I'm going to put here the r path. Then I'm going to put here the g path, and then I'm going to put here the b path. Okay, so this is done. So it is going to split the colors, right? And it is going to take, so I'm going to put here Audrey, AURDY, so that's how it is named. So I'm going to take this image, so let's close this. I'm going to take this image and I'm going to write it over here with red, blue and green components. So if I just do a build, okay, unsigned, signed, unsigned don't match. 40, line number 40. Okay, don't worry about it. Unsigned int, unsigned int. Is that okay now? Now it's matching, right? So let's build this again. Okay, so now it's done, and I say debugging. So it has read that this is audrey.emp and this is the header information, and it should have written 3 files over here. the red, the green, and the blue. Okay, so this is what we did in MATLAB. So same thing we have done over here. And let me see how much time I have taken. Okay, I'm going to do one more thing very quickly. In image write, I am going to take this entire function, right? So I'm going to take the entire function here. So just copy entire function. Okay, so I'm just going to say Control C, and here I'm going to shrink this, and I'm going to say Control V, and I'm going to call this one, instead of split colors, I will say RGB to gray. And in the RGB to gray, I just need one path, which is called gray.bmp, right? So gr path. Okay, so I'm going to just receive one file to write, so which is called gr path. So this will be fgr. Okay, and remaining I can delete. Okay, so here I am going to have red, blue, and green. So I'm going to have red, blue, and green pixels. Right, so once I have these red, blue, and green pixels, then I can go here and open the file in the read only, and I have done all that. Then for writing it, I have called this as fgr. So fgr is equal to, so this is called the gr path. So let's make it gr path. So this is going to write one of the file. So if it succeeds in opening that file, so if say fgr is not equal to null, so these conditions are not there, right? So is equal to null, then we failed in opening the gray file. And then I am going to copy the header of the original file to the fgr. So that's being done. And then for the image size, I'm going to read. Okay, so I'm going to delete this. I am going to delete this. And I'm going to delete this. Okay. Okay, so now I am reading first character at the offset, right? That is going to be red. So let's leave it in red. And then I'm going to read this in green. And then I'm going to read this in blue. So I have red, blue, and green. So here I am going to say ch is equal to red plus blue plus green divided by, so this is an integer division, right? Divided by 3. So that's the average of the 3 pixels. And then I am going to write it. Okay, so I'm going to write that character. I'm going to write that character to this file 3 times. 1, 2, and 3. So I am copying the same character, which is the average of the 3. Then here I am going to flush gr. And then close fgr. Okay, so I have converted the image to a grayscale image. Let's see how it works. So I am going to take this and do a prototype in the header file. So over here I'm going to add this, and I don't need this. Okay, so that's the prototype. I'm going to say save, and then I go to the main file, which is over here, and say after splitting the colors, I also want to do the RGB to gray. So I am going to just copy this, Control C, this is Control V. So this is going to do RGB to gray. So this is going to be F path, and here I want to add one more, which is GR path. Control C, Control V, call this as GR path, and this is going to be gray. So this is going to write gray to GR path. Okay, so now if I run this code, okay, it should also give me the grayscale image. So first of all, I'm going to delete this. Okay, so it's empty. So I'm going to read this file and convert it into RGB and convert it to grayscale. So that's what it is going to do, right? Okay, so let's go to the program and let's build it. Okay, what does it say? Undefined. What is that? Source undefined. Extern int. Okay, so wait a second, let me fix this problem. Okay, so we have the function over here, but we haven't included in the header file. So basically you have to include the other header file, which is image write. Okay, so now these two functions will be defined, and if I build the solution, so that's done, and if I run it, that's done, and if I look inside my folder, I have got red, green, blue. Oh, what is the mess up here? Why is it in blue, green, red? Why is it inverted? Okay, let me fix this also. Okay, another learning is that the device which is used for display is using BGR format. So the first one would be blue and the last one would be red. So sometimes it's RGB, but even in OpenCV it is BGR. So we stick with BGR then, if that's what it is. Okay, so having done that, I'll just compile this or build this solution and run and enter, and if you look here, you have got blue, green and red and a grayscale image. So basically what you do with a single line of code in MATLAB, you can see how much code I have to write in case of this C. Okay, and also if it is a let's say if it's a grayscale image and I want to pseudo color it, right? So I have to write, first of all, find out whether it's a grayscale or not. So the quick way to find out if it's a grayscale is when I'm reading the image, I'm going to compare. So let's find out. Let's write another code here under this file. Okay, so it would return a boolean, right? And I would say if it is black and white. Okay, so that's the code I'm going to write, right? So just 1 second. Okay, so boolean Just 1 second, bear with me. Okay. Okay, so I'm going to write another function here which will return a boolean, and it will tell me if it is a black and white image, right? And all I'm going to receive is a character, and which is going to be fpath, right? And that's what I'm going to do here. Okay, so for that, all I'll do is I'll do the regular stuff. Okay, okay, so I will do a file, say fb, and then I will have a unsigned int which will be a data offset. So I will read the data offset, and then I would have a unsigned int test. So basically how many pixels I want to test if they are same, and then say unsigned character red, green, and blue. Okay, so now what I want to do is I want to just open the file, which is fpath, and in a read binary mode. And if this file opens, then it's okay, otherwise fp would be a null pointer, right? And if it is a null pointer, all I would do is I would printf, okay, failed to open input file. Okay, so that's, and then say return false. Okay, so the next thing is else. I'm going to do all the processing over here. I'm going to find out the offset. So I'll say fseek, and here I'm going to say fp 10th byte from the beginning. So that's going to be fread, and then I'm going to say read the offset. So that will be in data off, and size of character, size of int, sorry, int, and then one integer, and then it's from this file. So once you are done with this is size of. So once you are done with this, you have the data offset. Then you are going to place the pointer at the data offset. So you are going to say fseek, place the pointer at the data offset, which is going to be data off, right, from the beginning. Okay, so this is how you place the pointer. And then I'm going to say test is equal to, let's say I want to test first 64 pixels if they are all equal, and then I am going to say for unsigned int I is equal to 0, I less than test, and then I can say I plus plus. So for this I'm going to read red, blue, and green pixels. So I'm just going to say fread. First I'm going to read the blue pixel now. So I'm going to read the blue pixel, right? And size of character is a pixel, right? Size of character 1 from fp. Okay, so I have read the blue pixel. Then I'm going to read the green pixel from the file. Okay, so I'm going to read the green pixel, and then I'm going to read the red pixel. So once I have read all the pixels, I'm going to compare them, right? So if red is equal to green and red is equal to blue also. Red is equal to blue means all the 3 pixels are the same. Then I am going to first close the file. So I'm not closing file pointers here because the file is not opening itself, right? So I will say here f close, and here I will say file pointer, and I will return true. So now this says if it matches, sorry, if red equal to green equal to blue, okay, if red not equal to green, if red not equal to green and red is also not equal to blue, and red is not equal to green, red is not equal to blue, and uh, green is not equal to blue, green is not equal to blue. Okay, so the pixels, now is this an AND condition? Not equal to green, all have to be true for this to be true. If either of them is not true, if either of them is not true, then you close this and pass on false. Correct? Okay. So did we? Okay. So this is what going to happen is it is going to test, and if either of the pixel isn't equal to the other pixel, then it's going to say that though this is not a black and white image, right? And then at the end, when you are done with this loop, right, you can say fp f close. So in case it is going through that, it has met the condition of that all pixels are matching, then you return a true. Okay, so now I have written this function quickly, which tells me if the picture is going to be a black and white image. So let's go here and copy to the header file. Okay, so I have copied it to the header file, and here what I'm going to do is in the process I am going to check printf and say new line, the picture is black and white, and I am going to write here %d or %d is okay, and then I'm going to write here call that function is black and white, and here I'm going to pass the f path. So here I'm basically checking if the picture is black and white. So the picture is not black and white, so it will return 0, right? So if I build this solution, okay, so I think it doesn't give the error. So if I go here and say debug, so it says the picture is black and white 0. So it's just saying that this picture is not black and white. So let's pick up a black and white picture. So go to the folder, and in this case this picture is black and white, right? MRI. So let's see if MRI shows up as a black and white picture. MRI, and then I would say build solution, and I'll say start without debugging, and the picture is black and white, true. So this is true. So this is a black and white picture. Okay, let's check it on another picture here, which is called plant cell. Okay, so I'll call this as a plant cell. Plant cell, and here I'm going to just build this, and I'm going to say start without debugging. Says the picture is black and white 1, so this is also black and white. So let's look at Lena, Lena, which is basically this picture, which is colored, right? So let's run this again. Build solution, start without debugging. Okay, so Lena picture is the picture black and white? Answer is 0. So basically it can check whether the picture is black and white or not. Okay, so I am going to comment out this one, RGB to gray. Okay, RGB to gray. So I am not going to convert RGB to gray, rather I'm going to do the reverse now. Okay, so what reverse am I going to do? So I'm going to write another function here. Okay, so that function I'm going to say is going to return white, and I'm going to say gray to RGB. So this is going to do a pseudo image, pseudo colored image, right? So what is it going to do? It is going to receive 2 paths, right? Just 1 second. Okay, okay, so let's go ahead and write it. So it is going to receive 2 paths. One path is going to be the input path, so I would say character, and call it f path. Then I'm going to say character, and I'm going to write here I would say w path. Okay, so I'm going to receive 2 paths. One is the source, other is this, and I am going to get all the information about from the header about the size of the file, and I'm going to, after that I'm going to do some stuff, right? Okay, so let's say, where did we do that? Over here, right? So we were split colors, right? So let's go to split colors. No, to this one only. So I need 2 file pointers, so I will just copy everything inside this. Okay, so I'm just going to copy everything inside this. So here I'm going to paste everything. Okay, okay, so I'm reading the file, and I'm have another pointer called gr. That's fine. Then I'm reading the character red, blue, green, width and offset. Okay, then I open the file in read only mode. Then I say, okay, if this is null, fail to open the file. Otherwise I am going to read the data offset. Then I am going to read the width of the file, the image, height of the image, and then the size of the image. And then here I'm going to open the write mode path, so that is called w path here. So that's the w path, right? So I'm going to open that, and if it is not opening, then it's say failed. Otherwise I am going to put this to 0, and here I'm going to do something. Okay, so here I'm copying the header as is, right? And here I am saying that, okay, so just 1 second. Okay, so I am going to read the blue, green, and the red, so which are going to be the same, right? So blue, green, and red I'm going to read here. So is this the function? Yes. So all of these are going to be same, so I'm not going to lose any information if I read it 3 times, because the file is going to have 3 repetitions of the pixel values, because it's a grayscale image, right? And then I have to colorize it, right? So I will put here very simple, I would say here, so this portion I can remove. Then I can say if I will just segment the image into 3 sections, right? One I will give to the red channel, other I will give to the blue channel, and then the green channel. So I will say ch is greater than, let's say, 171. So I have divided this into 3 regions. Okay, so I would say red is equal to ch minus 172 times of 255 divided by 83. So this is a range of 83. So if the gray level is in, if the gray level is in this range, I am going to assign it to red, otherwise I'm going to assign 0 to it, right? So just 1 second. Okay, so basically I have a red pixel which I have computed, right? And then I'm going to write it. So I'm going to write it to fwrite, and I would write here red, ampersand red, size of character in 1 byte, and I am going to write it to fgr, isn't it? So sorry for this typing mistake. Okay, so if it is this, then I'm going to do this, else I'm going to write 0. So let's create a 0 here. Okay, unsigned character 0 equal to 0. Okay, so I am going to write this to the stream as a red channel. Actually this is a blue channel, but it's okay. So here, okay, it's a blue channel, right? So write it as a blue channel only. Okay, first one is a blue channel, right? Okay, so the first character I have written is a blue channel. Let's see that. So I want to make it red. Okay, so if it is red, okay, let it be, doesn't matter really. Else I'm going to write a 0, fwrite ampersand zr, size of character 1 byte, NFGR. So I'm going to write here that, right? And then I'm going to check whether it is green. So I am going to go here and I'm going to check for the green case, which is going to be, let's say, between 85 and 71. Okay, so I would just go here and say if character is between 85 and 71. If character is greater than 85 and character is less than 171, isn't it? Yeah, character is less than equal to 1, less than equal to 171. Okay, so in that case I am going to put it into a green channel and say green is going to be equal to channel minus 86 times of 255 divided by 85. Correct? So this has gone there, and then I will write green. Okay, so I'll just copy this green. I'm going to write green to it, right? And then else I'm going to write 0. Okay, the next part which I'm going to do is, so basically this is unnecessary creating confusion. Okay, so the next part I'm going to do is if the character was less than equal to 85, right, then I am going to simply scale this as a blue, and I will do blue is equal to CH multiplied by 255 divided by 85. So that's basically blue, and then I will just write that blue there. So I'm writing to red channel, but this RGB and GBR, okay, there's this little confusion, okay, BLUE, else I'm going to write 0, right? Else I'm going to write 0. Okay, so I took a black and white image. I divided 0 to 255 into 3 regions. Okay, one region is from 0 to 85, 85 to 171, and 172 to 255. So I divided it into 3 regions and wrote it as 3 pixels. Okay, so this is done, and what I'll do is I will create a prototype for this one. Control C, in the header I am going to say Control V, and I'm just going to receive 2 paths. Okay, one is the input path, that is the output path, and I'm going to save that, and I'm going to go here and I'm going to say if is black and white, and I will input the picture which is f path. So if f path is black and white, then you are going to call that function, and that function is gray to RGB. Control C, Control V, and here this is going to be f path, and here I am going to put here another path here for RGB. So I'm going to say Control C, Control V, and say RGB path, and I'll call this as RGB. Correct. So it will be RGB path. RGB path. So now I am checking if the image is black and white. So Lena is not, so nothing will happen with that. So let's pick up moon, for example. Sorry. So unnecessarily it opened. Okay, let's look for a picture which is moon, and I want to colorize this picture, right? So I'm going to call this function on this moon. So let's make this as moon. Okay. So having done that, I'll also go and clear this. I just only want to see the moon colorized. Okay, so I'm going to just remove that. Okay, so here I am going to build the solution. Okay, so I don't see any warnings. So I'm going to run this on moon. So start without debugging. So it did write something. So let's see if it succeeded. Okay, so that's your moon, which is colorized. And let's look at the grayscale image of this moon. So this was the original moon, and this is the colorized picture of moon. Correct? So let me just copy this. New. Okay, and say file, save as, and let me just save this as Multiproc session 2. Okay, that's for my later update. Okay, so what did I do? I took the grayscale image and converted it to a color, pseudo colored image. Now what are these pseudo colored images used for? The pseudo colored images are going to give you a good visual what do you say, clue into what this picture is trying to tell you. So this is moon, and this is the pseudo colored picture moon. Okay, so now what more I can do is, let's try it with some other. For example, let's try with this plant cell. Okay, so this is also a black and white image, but I'm going to colorize it, plant cell, and I'm going to save it, and I'm going to say build solution, and I'm going to say debug start without debugging. So it has written that. So let's go in here, and that's the plant cell. Okay, so this is the plant cell, which is the colorized image, and let me see if I'm recording. Yeah, and this is the plant cell, which was a black and white image. So basically, sorry, basically you can see that colorizing the picture, okay, can give you more information if you are going to visually inspect this, not for the machine but for you. Okay, so this is a SEM image of the plant cell, and this is the colorized version of it. Similarly, if I look at the MRI, so MRI of this brain, right, this is a black and white image. So what I can do is I can colorize this MRI and see what it looks like. MRI, and say build solution, and say start without debugging, and it's done. Okay, so once it's done, I will go here and see what happened to the brain. So this is the MRI scan, which is colorized, and sorry about that, and this one is the gray level. So you can see how much more information can you visually get from this, right? So this is your black and white or grayscale, and this is your colorized one. Let's run this on one more because I'm enjoying this. So let's say I take a chest x-ray here, and I want to see what the corona patients, or let's say corona, this is their corona, right? So I want to see what happens if I take a chest x-ray of a corona patient. So it says chest x-ray. Okay, so I will call this as chest x-ray, and here I want to say bill solution. Okay, so chest x-ray. Okay, so now I'm going to run this. So it's done. So I'm going to go in here and see what happened to the x-ray. So this is the chest x-ray of a corona patient, right? So you can go here and see what happened over here. Sorry. Okay, so this is what you can see is happening in terms of x-ray, right? Chest x-ray. After you colorize it, okay, you will be able to see patches due to corona, right? So that's all that I wanted to cover in this session. Okay, and you can follow this and you will be able to do this on your own. Thanks a lot. Thank you.